Good evening, everyone. This is the Q&A session 11 from the playlist of motion in a straight line. And the question which I have taken for this session, it was asked in one of the medical entrance examination long time back. So the question here is, a particle is moving along the x-axis with an acceleration given by this formula, that is f is equal to f naught in bracket 1 minus small t divided by capital T. Here small t is the time and f naught and capital T are the constants. The particle has got zero velocity at t is equal to 0. So we have to find the particle's velocity when the acceleration is 0. Now here we have been given that f is equal to f naught 1 minus small t divided by capital T, so which is equal to f naught minus f naught small t divided by capital T. Now this acceleration can be written as dv upon dt, and this will be equal to f naught minus f naught into small t divided by capital T. Now yes, now this equation can be written as dv is equal to, this dt will be taken on the right side of this equation, so I will be getting the equation as f naught minus f naught dot t upon capital T dt. Now this can be written as, dv can be written as f naught dt minus f naught divided by capital T t dt. Now here we will be integrating this equation in order to get the equation for the velocity. So by integrating this equation, I will be getting the value as, so by integrating this equation, we will be getting the equation for the instantaneous velocity, which will be equal to, now v is equal to, this is a constant, so the integration of this will be equal to f naught into t minus this f naught upon t is a constant, so this can be taken outside, and the integration of this t will be equal to t square upon 2 plus I will be getting one constant of integration which I have written as c. Now so here we have been given one condition, that is the particle has got zero velocity at t is equal to 0. So if I put the value of t as 0 in this equation, I will be getting the value of c as 0. C will be 0 based on this condition, that is the particle has got zero velocity at t is equal to 0. So if I put the value of t is equal to 0 here, and the value of v is equal to 0 here, then the value of c will be equal to 0, and I will be getting the equation for the instantaneous velocity as v is equal to f naught t minus f naught upon t capital T into t square upon 2. So this is the equation for the instantaneous velocity of the particle, and now we have to find the particle's velocity when the acceleration is 0. So we have been given here four options, that is first option is 1 by 2 f naught into capital T, second option is f naught into t, that is capital T, and these are the two other options which I have written here on the left side, on this left hand side of the board. So here we have been given that the acceleration of the particle is equal to f naught 1 in bracket 1 minus small t upon t. So if f is equal to 0 here, then I will be getting that 1 minus small t upon t will be equal to 0. or it implies that t upon t, small t upon capital T is equal to 1, or it implies that small t is equal to capital T. So we have got the value of this small t, which is equal to capital T, when the acceleration of this particle is 0. So simply we have to find the particle's velocity when the acceleration is 0. That is, we have to find the particle's velocity when small t is equal to capital T. So I will be substituting this value of small t, which is equal to capital T, in this equation of instantaneous velocity. So V will be equal to F naught into T minus F naught upon capital T multiplied by T square upon 2. So this is the equation which I have got by substituting the value of small t as t in the velocity of the equation, and so V is equal to F naught T minus F naught into T upon 2, or the value of the particle's velocity when the acceleration of it is 0 is equal to 1 by 2 F naught into capital T. So the correct option here is 1 by 2 F naught capital T. That is, the option A is correct. So here we have been able to find the acceleration of the acceleration of the, or you can say the particle's velocity, first of all, by using the differentiation, and there we were able to find the velocity of the particle by integrating the function, that is dv upon dt is equal to f naught in bracket 1 minus small t upon delta t, and thereafter what we have done is that we have found the value of the constant of integration by using this condition, that is the particle is having 0 velocity at t is equal to 0, and then after that, since f is we have to find the particle's velocity when f is equal to 0, therefore what we have done is that we have substituted the value of f is equal to 0 and found the value of small t, which was equal to capital T. So thereafter what we did, we substituted the value of small t, which was equal to t, in the equation of the instantaneous velocity, which we have got by integrating the equation, that is dv upon dt was equal to f naught in bracket 1 minus small t upon t. So thank you very much for joining this session, and in the next session we will be coming up with a different type of the question, and the topic will remain the same, that is the instantaneous velocity and acceleration. So till then, have a nice day. Bye.